Greetings, let's solve this one with a limit substitution of variables inside a limit. X goes to 0 of this. We will use two properties, two quite common identities, and they're as follows. So first of all, as x goes to 0, this is a known limit we'll use. Another known limit we'll use eventually is this. So two known limits we'll use here, and substitution. So what substitution should we use? Well, I want something like a variable plus 1 in here. And therefore I'll say cosine x equals y plus 1. But we'll have to adjust the limit bounds, here. But actually it turns out that if x goes to 0, let's see where this substitution goes. Well, cosine x is y plus 1, so y is cosine x minus 1. So if x goes to 0, then y goes to where? Well, try to plug in 0 here. This is 1, so 0 as well. So actually it turns out, regardless of the substitution, we have the same limit, sort of value, for the new y. So now in terms of y, we will keep some things in terms of x in this expression, but not everything. So cosine x, using the substitution, I can rewrite as such. And then I can keep the x squared. But what I want in the numerator, gradually, to get ln of y plus 1 over y, to get that y according to this known limit, this one. Because we do have y going to 0. And we can have ln of y plus 1 over y that will go to 1, just like x plus 1 over x in ln up here will go to 1 as well. So, in order to get the y here, I can imitate it sort of by, for example, taking this knowledge, that y is cosine x minus 1. So cosine x minus 1 is y, actually, according to the substitution directly. But actually, we also need to take care of the x squared. And there's this other known limit, sine x over x is 1. So if I can somehow get sine in numerator as part of this whole process, that would be also useful, so we'll do that. So actually, I can multiply, by the way. This was a little bit forgotten, but it's important. Numerator was multiplied by cosine x minus 1, so denominator, so numerator has to have the same. An additional multiplication must happen numerator and denominator. So let's just always be careful about that. Now continuing the process with the next step, I can multiply numerator and denominator by cosine x plus 1 in order to get something like minus sine squared x. It's a trigonometric identity here. So I can write it out for it to be simpler to look at. First, the same thing, and multiply both numerator and denominator by the same again. I chose plus 1 because it will create a trigonometric identity eventually. And it connects with this thing that we had there, which imitated the y that we need for ln y plus 1 over y equaling to 1 as a limit as y goes to 0 also. It's like two identities used at the same time, interconnected case. So, interconnected situation where we have this. So x squared, we multiply additionally by this, so we'll do it to the denominator as well. But what gives this, both in denominator and numerator, actually, it would be almost an idea, maybe, to do cosine squared x minus 1 in denominator and numerator as well. But we only have to rewrite as such in the numerator, because in the denominator we will actually have to go back from cosine x minus 1 to y to get to make use of the ln y plus 1 in the numerator gradually. So we'll only rewrite it to sine squared x in the numerator. So actually, not to waste more space, this is in fact cosine squared x minus 1. But cosine squared x minus 1, don't forget, 1 minus cosine squared x is sine squared x. So this is also minus sine squared x. So be careful, not sine squared x, but minus sine squared x, because the two terms are switched with minus there, multiplied by minus 1. So this is multiplication, not actually addition. So let's also be careful about that. And now we can interconnect, already use one of the famous limits. Sine x over x is 1 as something goes to 0. And we know that even when y is going to 0, x is also going to 0. Because fortunately, this substitution allows that. This substitution told us that x goes to 0 and y goes to 0 at the same time. So even we converted it to y, x's are still left inside the argument, but we can still treat them as going to 0 as well. So we can make use of this famous limit. Sine x over x, we can spot it here, sine squared x over x squared. It's like sine x over x, limit, 1, and to the second power is 1 squared, so also 1. So this thing can sort of be eliminated out of the expression using this. So now we have this left. And now it seems like we have a redundant 2 parentheses here, but let's rewind back. Of course, cosine x minus 1 is y. And this might seem like trouble, but at this point, if we plug in 0, there's no problem. It won't cause the numerator to be 0. Cosine x is 1. So what we get is, first of all, this part, similarly like the sine x over x before they the 1, as the variable approaches 0, here even we explicitly have the same y. Y goes to 0, and then y plus 1 over y according to this is 1. So we can cancel these two out according to properties of limits. And all we have left is this. But now we can plug in directly the limit value. And let's be careful, we forgot one thing, the minus. The minus still stayed here, so we must write it. We forgot it, but let's be careful. So the minus would be, for example, we can write it here. And then I'll write it here. It was forgotten, but we have it back. So the final result, this is 1, so we have minus 1/2.